Hello and welcome to a new video on cryptography for everybody. Did you know that not only the Germans used encryption machines during World War II, clearly also the Allies used encryption machines, especially rotor encryption machines. And in today's video, we will have a look at the British Typex machine. I structured this video into 4 different parts. In the first part, we will have a look at an introduction to the Typex machine. Then we will learn how the machine actually works. After that, we will have a look at the keyspace size and the Unicity distance of the Typex machine. And finally, of course, we will do it in CrypTool 2. We will encrypt and decrypt using the Typex component. And we will also have a look at a really nice simulator on the web that simulates the Typex machine and also shows the internal workings of the machine. The Typex, also known as Typex, 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 or Typex, always written in a different way, is a British rotor encryption machine used in World War II. The Typex machine was used for encryption of the own communication, as well as deciphering German Enigma messages, since the machine was compatible to the Enigma machine. The Typex was more secure than the German Enigma, since it used 3 rotors. Also Enigma used 3 rotors, but additionally 2 stators, a plugboard and a reflector. Enigma didn't use these stators. Also the plugboard of the Typex was more sophisticated, and in later versions the reflector also. The Typex machine was developed by Wing Commander Oswin G.W. Lywood, who you can see here on the right side. Then Flight Lieutenant Coulson, Mr. E.W. Smith, and Sergeant Albert Lemon. There were several different versions of the Typex machine, including the Typex Mark I up to Mark 8, then the Mark 22 and the Mark 23. And a very nice, more detailed overview of the history of the Typex machine you can see on this webpage here. We will also have a look, as I already said in the introduction, on the simulator of that webpage, and I will also link this webpage below this video. How does the Typex machine work? The Typex machine you can see here on the right side. This is a Typex 22 machine, and the picture is from Wikipedia. I marked all the important components of the machine, and you can see these here on the left side. We will have a detailed look at the components later. The Typex machine has a keyboard, a plugboard, 2 stators, 3 rotors, a reflector, and printers for plain and ciphertext. You can see the printers here, the stators here, the rotors here. This, of course, is a keyboard. This is a plugboard, and this here is a reflector. In this version of the machine, the reflector can be rewired using this second plugboard here. Let's have a look at the components in detail. First of all, let's have a look how the components work together. If you want to encrypt or decrypt text, as with Enigma, you type on the keyboard. You press a button. Then current goes into the plaintext printer, and the plaintext printer prints the plaintext. Also, the current goes through the first plugboard. Then it goes through 2 stators. These 2 stators don't move. Then the current goes through 3 rotors. And finally, of course, it's reflected by the reflector. It goes back through the rotors, through the stators, through the plugboard again, and then into the ciphertext printer. And our ciphertext symbol is printed out. Of course, when you press the button here, the rotors rotate. And in contrast to Enigma, not only the first rotor rotated, moved the second and the third. At any time, all the rotors can rotate and they rotate much more often because they have much more notches than the Enigma rotors. Not only every 26 positions of the first rotor the second moves, it can be that there are more than even 5 of these connections between these rotors, these notches. So the second rotor moves much more often, and the third, of course, also. Now let's have a look at each component in detail. First, the Typex plugboard. It performs a simple substitution. That means it replaces a ladder with a plugged ladder. So current goes into the plugboard, then the operator could change the plugs so that the output is changed or the letters are substituted. And for instance here, this plug is connected to this plug to this, so these letters would be replaced. The plugboard is not reciprocal. That means it's not like with the Enigma's plugboard. With the Enigma, if we would substitute a letter X with a letter Y, then we have to substitute letter Y to letter X. Or the machine does that, because the Enigma is built in that way. In Typex, when we replace this letter by this letter, it must not that this letter, or it has not to be that this letter has also be to replaced by this letter. This letter then can be replaced with another one. This increases the keyspace size so that we have a larger keyspace size than with Enigma's plugboard. Let's have a look at the Typex rotor or stators. The rotors and stators are in fact the same. In the simulation we have 8 different rotors or stators, and you can use a rotor or as a stator. Each of these can be put into the machine in forward and reverse position. So when we have 8 rotors, since we can reverse the rotors, in total we have 16 rotors. A rotor has more notches, I already said that, than the Enigma rotors. In our simulator, the rotors have between 4 and 7 notches. So not only every 26 rotations a rotor moves the next one, it could be that every 8th or every 6th rotation or step it rotates or moves the next rotor. The rotor's electrical contacts with the Typex are doubled to improve the reliability. So instead of having only one contact here, we have 2, and here it's the same to make it more reliable. Sadly for us, the original rotors of the original Typex are not published and still kept secret. So the simulators use no official rotor definitions. Clearly in CrypTool 2, we also use not official rotor definitions, we use rotor definitions from well-known simulators. Let's have a look at a reflector. And a reflector reflects the current from one contact to another. So when current, for instance, here goes into A, it's reflected to, let's say, M. And when current goes into M, it's reflected to A. And in later versions of the Typex, the reflector is replaced by a second plugboard that allows to rewire the reflector. So you could change the plugs between the contacts of the reflector. Now that we know how the machine works, let's have a look at the keyspace size. And here I use the so-called Cybersheaf version of the Typex. The Cybersheaf is software released by GCHQ, and in that software you can also find a Typex. And we use now this Cybersheaf version for computing the keyspace size and Unicity distance. First of all, you have to select rotors and stators. You have 3 rotors, and we have a set of 16 different rotors. In fact, we have 8, but as I said, we can put it in the reverse direction into the machine, so we have 16 rotors to choose from. Since we have to choose 3, we have 16 to the power of 3. In this calculation, we assume that you can use the same rotor again. So 16 to the power of 3 for the rotors. Then we have 2 stators. We have 16 to the power of 2. And we have to multiply these. This is about 1 million possible rotor selections for the rotor stator selection. Then we have to choose the start position of the rotors and stators of the machine. We have 5 rotors and stators in total. Each of these has 26 letters, so we have 26 to the power of 5, which is about 11,800,000 different start positions. Then, of course, we have 26 plugs, and therefore we have to, or we can choose 26 factorial different plugboard settings. We have a total keyspace size of the product of all of these. So we have to multiply the rotor status selection with the start positions and the plugboard setting. This is 1 million multiplied 11.8 million multiplied 2 to the power of 88. That gives us a total number of 2 to the power of 131.88 for the keyspace size. Now let's compute the Unicity distance. The Unicity distance is the minimum length of ciphertext we need that with cryptanalysis we would find only one valid solution. If we have ciphertext that is shorter, then with a very high probability we find different valid plaintexts for the given ciphertext, and we cannot distinguish between these. To compute the Unicity distance U, we have to divide the entropy of the keyspace size by the redundancy of the language, in our case English. Our entropy of the keyspace size is just the exponent here of this number. This is 131.88. This is the entropy of the keyspace size. And the redundancy of the English language is 3.2. And when we divide these two numbers, we get 41.21. So our Unicity distance would be 41.21. So we would need more, or at minimum 42 letters, that we can obtain a valid solution when we cryptanalyze the Typex. Now that we know how the Typex machine works, let's have a look at the implementation in CrypTool 2. Let's encrypt and decrypt using the Typex component of CrypTool 2. And after that, I want to show you the simulation virtual Typex, which is a really nice simulator of the Typex machine in the browser. I'm here now in the Start Center of CrypTool 2. I use the CrypTool 2 nightly build 9535.1. And if you also want to use the Typex component of CrypTool 2, you need at minimum this version. And I want to show you how you can use the Typex in CrypTool 2. To do so, we first create a new workspace. In CrypTool 2 then, in the components window here, we search for Typex. And we put 2 times the Typex component onto the workspace, since we want to encrypt and decrypt text. Then, of course, we need text. We have a text input. This is our plain text. And then we need 2 text outputs, one for the ciphertext and one for the decrypted plain text. Let's change these to biggest width and biggest height so that they share the same sizes. And then we have here ciphertext and we have decrypted plain text. Now we need to connect all the components. We connect the plain text component with the first Typex, and of course then the Typex with the ciphertext text output. Then we want to decrypt, and we need to connect the second Typex to the decrypted plain text text output. Now let's write a test text. Hello world. This is the test of the new Typex component of CrypTool 2. Now let's have a look at the settings of the components. The Typex component offers different machine types. We have CyberChef, test rotors. These are a set of rotors that just forward the letters. Then we have Enigma 1, rotors of the original Enigma 1, and we have 3 other versions. I use the same rotor definitions as the simulator virtual Typex that I will show you later. Then you can select the handling of unknown symbols. Since the Typex can only encrypt and decrypt the letters here and not the space, for instance, you can change here the behavior. You can ignore these, so they are left in the resulting ciphertext. You can remove these, or you can replace these with question mark. I like the setting ignore, that we have the spaces still in our ciphertext here. Then you can change the rotor and stator positions. The last 2 letters here are the start positions of the stators. Of course, since these are the stators, they don't move. And we have the start positions of our 3 rotors. Then you can also change the ring positions of the rotors. I omitted the rings in my presentation in the start of the video, since the rings are not cryptography relevant, and you can find, so what do the rings do? They change the rotation of the notches to the alphabet of the rotor. And you can always find an equivalent rotor position then that removes the ring positions more or less. Then we have the rotor selections here. You can select between 8 rotors for the 3 rotors here. And you have to read from bottom to top. So the current goes first through the first stator, then to the second stator, then rotor 1, 2, and 3, and then through the reflector and backwards. You can also select that you want to have a rotor in reversed order, but I keep these settings here. That are the default settings. Then you can select the reflector here. We have also the same options here, like with the machine type. And then you can change the plugs of the machine, so of the plug board. But I also keep the plug board here unplugged. Now when we press play, you can see that we get our ciphertext. Symbols that are not known, so non-alphabet letters, are just kept. And then we have our ciphertext here and we have our plaintext here. And clearly, when we decrypt and we have a different rotor position or stator position, we cannot decrypt in the right way. We have to change both machines to the same setting, and then it decrypts again. Yeah, and this is how the new Typex component in CrypTool 2 works. You can now download the current nightly build and test the components on your own. And as I said in the introduction of the video, I now also want to show you the virtual Typex implementation that you can use in your browser. I'm here now on typex.virtualcolossus.co.uk, and this website is really nice. You can read all the documentation here and find out more about the Typex and the virtual Typex. This is really interesting, and I suggest that you have a look at this. And you can also run the virtual Typex machine. And that is what I want to do now. You press on Run Virtual Typex, and you get this really nice Typex simulator here. And as you can see, it is the same version of the machine that I have shown you in my slides. What can you do here? First of all, what can you see here? On the left, you see the plaintext printer. On the right, you can see the ciphertext printer. And you can, of course, what I also already did, scroll here, and then you see the other components. You have here the keyboard, you have the reflector here. Behind this, you can see the rotors. We will see this in a minute. And you can see here, this is not the reflector, this is the plug board. This is the reflector here. But this is also a plug board because you can change the plugs of the reflector. You can basically click on everything and use everything that you can see. It's really amazing simulator. So let's change the rotors. And I want to also use the GCHQ rotors from CyberChef. So you click here on CyberChef. It automatically opens the machine and removes the previous rotors. And now you have the CyberChef rotors here. And you can use the CyberChef rotors by just dragging and dropping these rotors into the machine. So we have the 2 stators here. We have to look from right to left, stator 1, stator 2, then rotor 1, 2, and 3. So we put the rotors into the machine. Then lock these into position. And what you can also do here, you can change the start position by just moving the rotors. What is also really nice here, and I don't know if you can hear it, you have here this button. You should try it when you try the simulator on your own. When you click here, you get the audio output of the machine. And I think you may hear these, otherwise I will just increase the audio volume. And now, when you use the machine, let's press H, E, L, L, O. You can hear the machine actually working. All the moving parts make sound. I really like this, but I will switch it off. I don't know how it works on video. So I pressed hello, and I want to also have world. So W-O-R-L-D. And every time I press a button on the keyboard, a key on the keyboard, you can see that the rotors here, the 3 rotors, move. Also, you can see that you get out here the plaintext. And when I press here, I can see the plaintext here. We have hello world. And when I press here, you can see the encryption. Now, when I want to reset the machine, I can just press here and reset the counter to 0. And I can move the rotors back to the original position, to the start position that was AAAA. If you want to change a plug in the plug board, you can also use drag and drop here. Let's change A and B. And you change the plug board. I also want to change the reflector to the Cyberchef reflector, so I click here and it switches the reflectors. And now I have the Cyberchef reflector. What is also really nice with this simulator, you can have a look inside the machine. So we can close the cover here, and then you can make the machine transparent here. As you can see, this is 100 what we had, and then you can change the opacity. And you see inside the machine, you see the moving parts of the machine. And when we press here, you can see that all the parts inside the machine are actually working and moving. So a really nice and well-made, accurate simulator of a real Typex machine. Yeah, and this is everything I wanted to show you in this video. I first introduced you the Typex machine. I showed how it's built, all of its components. Then we had a look at the Keyspace size and Unicity distance of the machine based on the Cybersheaf simulator. Then we had a look at our new implementation in CrypTool 2 that is also now available in the new nightly builds. And finally, we had a look at this really nice simulator here that you can also use to simulate a real Typex machine, or more or less real. Clearly, the rotors used here are not the original ones. As I said, these are kept secret, sadly. Yeah, and this is everything I wanted to show you in this short video. If you like what I do, please give a thumbs up. This really helps me and makes CrypTool 2 and cryptography more popular. Also, if you did not yet subscribe to this channel, please do so. This really helps me to grow the channel and make CrypTool 2 more popular. Also, if you want to get notified when I upload new videos, hit the bell icon. So thank you very much for watching and see you in the next video.